Greenhouse horticulture is an important sector since it provides us with fresh fruit and vegetables. However, nowadays growers are faced with a number of challenges. First, the availability of skilled staff that can oversee the complexity of a production system like this. And second, the increased complexity of the production system requires that we move to a more data-driven approach. And therefore, in the AGROS project, we work on the development of autonomous greenhouse systems. Our dot on the horizon is a fully autonomous controlled greenhouse system that is based on sensor data and remotely controlled via an intelligent algorithm that has an objective goal function, like, for example, net profit. In the past few years, we've been developing the building blocks for this validation trial. So the physiological knowledge, the sensors, and the intelligent algorithms. And now we bring all these building blocks together in this validation trial.
In the AGROS project, we have sensor data on the greenhouse climate, the crop itself, as well as in the root zone, used for the decision-making and signaling of the crop in an automated manner. In close collaboration with the AGROS partners, we have selected a list of sensors and we have deployed them in previous and in the existing validation AGROS trial. The aim of the sensors is to increase the understanding of activities such as crop transpiration, water uptake, light interception within the crop, as well as growth rates. We collect the data from different sources and we are sharing the data among different platforms before we take any decisions on the operational activities. For the digital twin approach, the sensor data is used in order to create a virtual climate and crop simulator as close as possible to reality in order to make informative decisions regarding the activities of the coming period, knowing the latest situation of the growing environment. For the reinforcement learning approach, being more of a black box approach, we are using sensor data of mainly default sensors of measuring boxes in the greenhouse to determine the current situation and make the decisions on the next time steps. In conventional greenhouses, the physical presence of experienced growers is sufficient in order to determine what are the growing conditions and what decisions are need to be made in the next steps. However, in autonomous greenhouses, whether we are talking about lower or higher level of automations, sensors are important in order to have standardized, objective and remote decision making.
So the control algorithms that we work on in the AGROS project, they of course need some feedback from the system that they're controlling. So we try to get feedback from the climate, of course, so the inside temperature, the outside temperature, the weather, the incoming radiation. But in this project we also want to get some feedback from the crop itself. And of course these parameters are a bit harder to measure. So for instance, we like to measure the growth rate of the cucumber and the leaf initiation rate. Now, you can do that manually, but here we want to move towards an autonomous system. So we also want to have autonomous sensors. And for that purpose we now use cameras. And so with these cameras we try to measure the fruit growth rate and the leaf initiation rate, or the leaf formation rate. So the cameras, they send out one image every 15 minutes. They're sent to a server and then we apply deep learning algorithms to detect the cucumbers and the leaves. And for the fruit growth rate, we calculate the length and the width of all the cucumbers over time. And from that we estimate the fresh weight. If we do that for multiple cucumbers over multiple days, we get a nice curve and it shows the fruit growth rate of the compartment as a whole. And for the leaves, we take a similar approach. We track about 7 leaves for each plant. And then we try to detect the exact moment that a new leaf is part of that detection. And if we do that for several plants over several days, we can combine all that information and come to one number that's the average leaf formation rate of the compartment as a whole.